Hi guys, it's Vivs here from Slide Nerd. In this video, I'm going to talk about how we can set up Volley Singleton to work in our app. Now previously we talked about what is the Volley library and how it works. In this video, let's get the Singleton running. First, read this question. Why a request queue for Volley must be Singleton? And here the answer is given as Volley is designed to queue all your requests. It wouldn't make sense to have more than one queue, and therefore Volley is a Singleton. Now this simply means that across all our activities and fragments, if we want to use Volley library, we need to create a singleton class that supports the request queue and image loader. So let's begin by doing that. Let's create a class that will act as a singleton containing our request queue in Android Studio. We'll call this class as Volley Singleton. So we have created a reference to our class object over here. Since we don't want other classes to use our constructor, we are going to make the constructor as private over here. Now we construct a static method that is going to return an instance of our class Volley Singleton. So inside our static method, which is called getInstance, it returns an object of type Volley Singleton. If our object or reference is null, we create a new object and return that object out there. Create an instance variable of type request queue inside your Volley Singleton. Now let's initialize this inside our constructor by simply saying mRequestQueue is volley.new request queue. And as you can see, it's gonna need a context. Now here, you're not gonna pass an activity context or some other type of context. What you need here is the application context. So let's take a look at how we can get that. We are going to require a custom application class. So we are going to go to material test and create a new class which is called my application in this case. And this is going to extend from the standard Android application class that we usually have. And of course we need to list this inside the manifest as well. We create a static variable called sInstance of type my application, and we initialize that inside onCreate. Now if you remember, the onCreate is going to be called right before anything runs inside your app. So going down here, we can return that instance by making another static method called getInstance here, and you can simply return sInstance from over there. The same way, we can also make another method that will return the application context from here. So this method called getAppContext has a return type of context, and it is simply saying sInstance or our application's instance dot get application context. Now we can use this inside our other class, which is Volley Singleton, by simply going here and saying my application dot get app context over here. Now most of all, we need to add this to the manifest file. So we simply go down here to manifest.xml, and here in the Android application, we simply specify the application class by saying Android name equals to dot my application, because it's in the main package of our app over here inside material test. Inside our Volley Singleton class, now we make a method that will return our request queue so that others can use it. We can simply say public request queue, and we can say get request queue over here. Now time to test if our singleton actually works the way we expect it to. So we can go down to my fragment here, and if you remember, we already constructed a request queue in the last video. We are going to replace this with our Volley Singleton and check if this is working or not. So instead of saying volley.new request queue get activity here, we can remove that, and we can say Volley Singleton dot get instance dot get request queue over here. And if this still works, that means our singleton is working. Let's test it. So there's our main activity in both cases in which we are going to run this. So there's our pre-lollipop and lollipop, and as you just saw, the request is running, which means our singleton Volley is functioning properly. Now what we need to do is make a strategy for storing images or caching images in our app as well. So let's get to that. We first take a look at the documentation for the class image loader. It says helper that handles loading and caching images from remote URLs. The simple way to use this class is to call get, pass a string, and an image listener object here. Also it says notice all the function calls to this class must be made from the main thread, and all the responses will be delivered on the main thread as well. Further, if you take a look at some of the nested classes that are out here, one of them is imageLoader.imageCache. The other one is imageLoader.imageListener. Now let's take a look at what this image listener basically does. As you can see, it says interface for response handlers on image request. The call flow is this. 1. Upon being attached to a request, the on response will be invoked to reflect any cached data that was already available. If the data was available, then the response.getBitmap will be non-null. After network response returns, only one of the following things will happen. Either the on response is called or the on error response is called here. In other words, it simply means that first the cache dispatcher is going to be triggered to check if the image is present in the cache or not, and if the image is already present in the cache, then you have the response.get bitmap, which will be not null. Otherwise, if you see the on response method here and there's the on error response, that's going to be triggered. One of them will be triggered depending on whether there was an error while fetching the image from the network or not. So if you go back to our image loader class, you will notice that in our constructor, it is going to ask you two things. One is a request queue, the other is an object or an instance of image cache. Now let's take a look at what this image cache is again. Simple cache adapter interface. If provided to the image loader, it will be used as an L1 cache before dispatch to Volley. In other words, whatever object you provide here is supposed to be an implementation of some form of cache that will be used by Volley as an L1 cache, as they say over here. They say implementations must not block implementation with an LRU cache is recommended. And as you see, there's two methods. There's a get bitmap and there's a put bitmap, in which we are going to store the bitmap inside your cache. Now let's take a look at how we can implement this. Now we have used an instance of image loader which will be used throughout our app. We simply go inside the constructor and initialize that by simply saying image loader equals to new image loader here. It's going to need two arguments. If you remember, one is the request queue, which we have already initialized at the top. The second thing it's going to need is an implementation of image cache interface. So we can simply make our own implementation here by saying new image cache, and we have to manage our caching mechanism over here. We need some object that is going to work as our cache, and the best representative for that is LRU cache class in Android package. So here if you see, it says a cache that holds strong references to a limited number of values. Each time a value is accessed, it is moved to the head of a queue, and when the cache is full, what happens is basically the value at the end of the queue is removed and may become eligible for garbage collection. Now again, they've talked about how they have given a size to it. As you see, the LRU cache object requires a size here, and in this case they have given a size of 4 MB. But assigning size is a very tricky business, and there are several ways to do this. In fact, there's a nice debate going on in Stack Overflow on how you can initialize or how you should size the LRU cache. We have created a variable of LRU cache within our anonymous class image cache over here. Now inside that we need to specify a size. Now the way we are going to do that is something like this. We are going to use the Java's max memory constraint to figure out how much size should be given. Now there's a whole debate going on here in Stack Overflow, as in what is the max memory, what is the total memory, what is the difference between them. So in this video I'm not going to get into that. But to give you a rough idea, max memory is the total amount of memory that you can ever take from the JVM, while total memory is the currently allocated memory for your process. Now free memory is variable because as you start garbage collection, the amount of free memory available changes out here. So with that, we are going to go back and we are going to say runtime dot get runtime dot max memory. Now this is going to be in bytes, so we got to make sure that we divide that by 1024 to give us something in kilobytes. So we're going to take that and further divide it by 8 to give us the size of our cache. Ensure that you typecast this long value to a proper integer, and then inside our get bitmap method, we're going to simply return the entry from our cache if it is present out there. Inside our put bitmap method, ensure that you store the image inside our cache. So with those two statements, our cache is complete. Now all we got to do is return an instance of our image loader to other activities and fragments so that we can use them outside our singleton. So now I go here at the bottom of the code and add a method called getImageLoader, where we return an instance of our image loader. So this completes our setup for the Volley Singleton class that we are working with. So in this video, I have showed you how to set up the Volley Singleton, and I have also showed you how we can use the image loader. In the next video, I will make several fragments inside the tabs and load data from Rotten Tomatoes API. In the meantime, if you like what you saw, please like this video, share this video, subscribe to Slide Nerd, and catch you guys later. Have a nice day.